Alright, welcome to chapter 6, and in this chapter we're going to deal with rational expressions and equations. In this section 6.1, we're going to talk about rational expressions. So we're going to talk about how to determine something called the non-permissible values for a rational expression. So we'll talk about that, and how to simplify one. Okay? So, first of all, a rational expression is basically like some kind of a fraction. So the expression x over 2 is a rational expression, or 2x plus 2 over 4x plus 7, that would be a rational expression. So any kind of a fraction. A non-permissible value turns up in rational expressions because the denominator cannot be a certain value. It can't be 0. So for instance, in this example up here, if whatever values of x that make the whole denominator 0 are not allowed, that is a non-permissible value. Because you cannot divide by 0, that would be an undefined expression. So for instance, in this example right here, 4x plus 7, if we set that to be 0 and solve for x and get x to be negative 7 over 4, so x cannot be negative 7 over 4, otherwise this would be 0. Everything else is allowed. Okay? So, you can take a look at the example, take a look at how I walk you through finding non-permissible values. I will do the practice problem. So, very simple. Okay, you take a look at the denominator, 3bc, and you set it to be 0. Okay, set the denominator to 0. Okay, so 3bc equals 0. Then you solve, or you kind of simplify this. This comes out to be bc equals 0 when you divide by 3. And this implies that b equals 0 or c equals 0. So therefore, non-permissible values, here we go. What is non-permissible here? Well, that would be b cannot be 0 and c cannot be 0. Oops. Either of those would result in a denominator that is 0. Okay? So for b, we're going to set x plus 2 and x minus 3 to 0. Notice how this is already factored. Okay, which is nice. If it was expanded into a trinomial, you would have to factor it first to determine what values would set this to be 0. So here, x cannot be negative 2, x cannot be 3. Okay. And for c, this is y squared minus 4 equals 0. This is a difference of squares. So y cannot be 2, y cannot be negative 2. Those are the non-permissible values. Hopefully that makes sense. Okay? Typically the questions will ask you to simplify them and identify the non-permissible values. Okay? That'll be like the next question. So I just mentioned simplification. Okay, to simplify something, let's get rid of that b there. You need to basically divide both the numerator and denominator by any factors that are common. So when you look at this guy right here, this is a quite easy example, but you can see that you have m cubed times t over m squared times t to the 4. So there are factors that are common between them, like m squared and t, right? So here I rewrote it like with the factors outside of it, so they can cancel. Okay, and that leaves you with the simplified version. But notice how here are the non-permissible values. So my question to you is, what step did they determine this? And it's pretty clear that you get this from the start. Okay, very important that you pay attention to this. See how m cancels out of the equation, so it's not actually in the denominator at the end. Yet it still can't be 0, because if you plug it into the first equation, then clearly you're going to get a 0 in the denominator. So to get the non-permissible values, you always check back to the start or one step after that before you cancel any factors, basically. So let's do some examples. See, here are the examples I gave you. Here are the written explanations. Hopefully those made sense to you. I'm going to go ahead and do the practice problems. Here we go. Simplify each rational expression. What are the non-permissible values? Okay, so we'll discover the non-permissible values as we move forward. But the first thing I'm going to do is I'm just going to factor. Okay, I'm going to factor the top and the bottom. So it's when we factor the top, we can get, let's see, we need 5 and 2. Think this will work. If this is a negative, and that's a positive, right? And this is all over 5 times 2 again. That's positive, that's negative. Look at that. So before I go on any further, we already know now that y cannot be negative 5. Y cannot be 2. Okay, so these are the non-permissible values. I'll put non-permissible. Okay. Now, we can move on here and we can cancel off this factor to leave us with 2y plus 5 over y plus 5. Okay. And this is simplified. Okay, you can't cancel out this y plus 5 because the 2 is out front. So here we have our final answer as far as I can see. For part B, we're going to, in this case, factor like again. On the top we actually can factor out a 2, so we get 3 minus m. On the bottom that's a difference of squares. We're going to get m minus 3, m plus 3. And right away we have our non-permissible values, which will now be m cannot be 3, m cannot be negative 3. Okay, maybe I'll circle the non-permissible values in blue all the time. Okay, now it appears that we can't cancel anything, but we can actually factor out a negative. Okay, we're going to factor negative 1 from 3 minus m. Okay, on the numerator, and that's going to give us negative 2 m minus 3 over m minus 3 m plus 3. These will now cancel, and you're left with negative 2 over m plus 3. And that's it. So the nice thing about rational expressions, as opposed to radical expressions, like we did in chapter 5, is you don't have to rationalize, you don't have to rearrange this denominator in any way at the end. Okay, we're just done. Alright? Now the last question will be kind of just a rearrangement of everything we've done. Okay, there's nothing new to learn here, so let's just do something else that's a bit different. Let's take a look at this one. This time we have x and y. Okay, so non-permissible values will be interesting. So let's take a look at this. This is the guy right here. 16x squared minus 9y squared over 8x minus 6y. Part A, what is the non-permissible value for y if x equals 3. Okay, so let's just plug x equals 3 in and see what the expression comes out to be on the denominator. We really don't care about the numerator. So for part A, x equals 3 implies that the denominator is 8 times 3 minus 6y. And we're going to set it equal to 0 because we're looking for the non-permissible values. So this comes out to be 24 minus 6y equals 0. Which comes out to be the following. Y is therefore equal to 4. Positive 4. Okay, therefore, the non-permissible value for y is y cannot equal 4. Okay. Pretty straightforward, you guys. Pretty straightforward, eh? Very nice and easy. Part B, evaluate the expression for x equals 1.5 and y equals 2.8. This is really just a computation question. Very simple. We can make it easier on ourselves, much easier on ourselves, which is how I'll show you how to do it if we factor everything. Again, you can go ahead and just plug it in and compute. That's totally okay. But we might as well play along with this question. This is a difference of squares at the top. So what this actually comes out to be on the top is 4x minus 3y times 4x plus 3y. I hope this factors. I think this will factor. If we take out a 2 on the bottom, we get 4x minus 3y. Oh, yes. Then you can see these cancel, and you're left with 4x plus 3y over 2. And x equals 1.5, y equals 2.8. Now we can plug those in. For 1.5 plus 3 times 2.8 all over 2. And when you compute this, 4 times 1.5 plus 3 times 2.8 divided by 2 comes out to be 7.2. Okay, so that's basically it. So a very nice way to ease into this section, to this chapter. Of course, complete the practice problems and ask me if you have any questions. And I'll see you in section 6.2.